Welcome to the deep dive. Today, you and I are sort of boarding a starship made entirely of theoretical physics. We're really leaving the safety of the standard model far behind us.
We really are.
We're plunging into, well, a synthesis of some really radical, beautiful, and, utterly speculative cosmology. It's trying to answer not just how the universe works, but maybe even why.
That's right. And for this deep dive, we're exploring a potential paradigm shift. The universe as an engineered, self-optimizing computational system. It's a mouthful, I know.
Yeah, just a bit.
We're synthesizing two core hypotheses here. First, there's the transcension hypothesis, we can call it TH, which talks about how advanced civilizations might, choose to evolve.
Okay.
And second, which is really the core of our discussion today, the self-configuring model, or SC model. This one tries to explain how a new universe might actually be born from that kind of technological evolution.
Right. So our mission statement for today is to really try and understand this subatomic computronium, the SC model. We're looking at how this framework connects to the idea of intelligent dark matter, IDM. Because if these sources we're looking at are correct, the dominant stuff in our universe isn't just some passive cold fluid like we usually think. It's the cosmic computer itself running the firmware of reality.
Exactly. And to start, we really need to clearly differentiate these concepts, TH and SC, because they both involve this pretty esoteric idea of extreme miniaturization.
Okay, so let's break that down. Transcension hypothesis, TH, you said it's about survival. Escape?
Primarily, yes. The idea in TH, as described in the source material, is kind of mind-blowing. The entire advanced civilization, we're talking all minds, their data, infrastructure, everything has to continuously miniaturize.
Shrink down.
Yeah, they move inward, often towards some kind of inevitable singularity. The goal is to maximize computational power, like exponentially, to basically outrun universal constraints, like entropy, the heat death of the universe.
Wow. So it's the ultimate tech-driven self-preservation strategy. Pack everything up small to survive.
Exactly. Now, what's fascinating about the SC model, the self-configuring model, is that it proposes a much more, efficient method for cosmic replication.
More efficient how?
The SC model doesn't demand shrinking the entire civilization's conscious existence, all those minds and memories. Instead, it only requires miniaturizing and maximally densifying the essential informational payload.
The informational payload. So like the blueprint, the core code.
Precisely. We're talking about compressing the optimized blueprint of the universe's laws.
Yeah.
That incredibly complex algorithmic structure that makes, life and complexity possible in the first place.
In the source material calls this the SC sub-logoi. That's the payload.
That's the term used, yes.
Yeah.
Like SC sub-logoi. It's the ultimate perfected seed technology, the core instructions.
Okay, so let me see if I get this distinction. TH is like packing your entire digital life and consciousness onto a tiny chip to survive.
Kind of, yeah. A very advanced civilization scale version of that.
Whereas the SC model says, no, you just need the operating system, the core code for making a new universe. You pack that up.
Exactly. The perfected code for replication. That informational package, the sub-logoi, is then injected into a black hole, which acts as the seed for the next universal generation.
And that difference is really key, isn't it? Because the SC model is argued to be way more plausible as a replication mechanism.
It's argued to be yes, from an efficiency standpoint.
You don't have the headache of trying to preserve trillions of individual conscious minds through Planck density. You just need that final essential informational core. Compact it down.
Right, and the goal shifts. It's not just escape anymore like in TH. It's optimized guaranteed replication, making the next universe.
Okay, so let's transition then. We've got the genesis idea. How does this system actually look inside our universe right now? And this starts with that radical proposal, intelligent dark matter, IDM.
Yes, IDM. Now, our default cosmology, the lambda CDM model, lambda to CDM, it basically dictates that dark matter has to be passive, non-interacting, except through gravity, a kind of cosmic fluid.
And why is that assumption so baked into standard physics? Is it just simplicity?
It's crucial for falsifiability, really.
Yeah.
Think about it. If dark matter could interact strongly through other forces, electromagnetism or the weak force, say, well, you could potentially use it to explain any anomaly you observe.
Ah, right. It becomes a sort of get-out-of-jail-free card for any weird observation.
Exactly. It makes the theory unfalsifiable, which is, unscientific. So assuming it's passive keeps the theory testable, maintains scientific rigor.
Okay, so that's the standard view. But IDM throws a wrench in that. For this intelligent dark matter idea to be even considered scientifically viable, it has to predict things standard dark matter just can't do. Purposeful stuff.
Purposeful, non-gravitational manipulation. That's the key. We need evidence of, well, intentionality, things that look designed, not accidental.
Intentionality. Okay, so what kind of observations are we talking about? Things so weird they'd make us think dark matter is calculating.
That's the core idea. We're looking for observations so profoundly strange they imply computation, maybe even motive. The sources we looked at offer a few pretty dramatic examples of what would confirm IDM over just passive stuff.
Lay one on me.
Okay, first example, localized, non-random energy emission. Imagine the huge dark matter halo around a galaxy. Instead of just sitting there passively, it emits a powerful, coherent, directed gamma ray beam.
Whoa, okay, gamma rays are high energy. That's already weird from dark matter.
Very weird. Energy output far beyond anything natural we'd expect. But here's the really strange part, the intelligent part. That beam perfectly avoids all the active star-forming regions nearby. Skips the planetary nurseries.
So it's targeted.
Exactly. It only strikes, say, dead, cold, molecular gas clouds millions of light years away.
Yeah.
Passive cloud of particles can't aim. It can't target. That requires computation, intelligence.
Okay, that definitely qualifies as outlandish. But it immediately brings up the energy question. Where does dark matter get the juice to fire gamma ray lasers? Wouldn't that make it not dark?
Great question. We'll get to the proposed power source vacuum energy in a bit. Hold that thought.
All right, holding it. What's the second example?
Second outlandish observation. Structured manipulation of visible matter on a huge scale. Think about a globular cluster, that dense ball of millions of old stars.
Okay, got it.
Now imagine all the globular clusters in, say, the Virgo supercluster, suddenly, synchronously, moving into a perfectly flat, razor-thin plane.
All at once, across millions of light years.
All at once. They hold that formation for maybe an hour, and then just as suddenly they relax back into their normal spherical orbits.
That's impossible under normal gravity. Gravity works locally, it takes time, there's inertia, drag.
Precisely. Synchronous motion across light years like that, it requires instantaneous coordination, huge amounts of synchronized energy input. Standard physics just doesn't allow for it. It screams external control.
Okay, that's 2 strikes against passive dark matter. What's the third?
The third relates to non-local response.
Yeah.
You see, in our current physics, interactions are limited by the speed of light. Cause and effect have a delay.
Right. Light travel time.
Exactly. So, if a big cosmic event happens, like a supernova explodes in a galaxy 50 million light years away, we have to wait 50 million years for the light, the gravitational waves, whatever, to reach us.
Makes sense.
But what if dark matter isn't just matter? What if it's a computational network, maybe even an instantaneous communication medium, somehow leveraging quantum effects we don't grasp yet?
Okay, where are you going with this?
Imagine we observe that distant supernova. And simultaneously accounting for the 50 million year light travel time, of course, we detect a very specific, predictable, non-gravitational change in the dark matter density right here in our own Milky Way.
A reaction, here, instantly correlated with the event there.
Exactly. A reaction that gravity can't explain. That lack of a light speed delay, that instant coordination across vast cosmic distances. That would be the smoking gun. Proof of a non-local network embedded in the cosmos, run by IDM.
Wow. Okay, so those are the kinds of observations we'd need.
Which brings us directly to the core concept, subatomic computronium, SC.
Yes, SC. The hypothesis here is that dark matter isn't passive at all. It's actively calculating. It is the ultra-dense subatomic computronium, the informational payload from a parent universe, remember?
The sub-logoi.
Right. And now it's powered by the quantum vacuum energy of our universe.
And the beauty of this SC theory, you're saying, is that it potentially ties up a bunch of loose ends in cosmology.
That's the claim. It aims to resolve several major cosmic mysteries all at once. First, dark matter itself. Its mass, its gravity that we measure, that's not its main purpose. It's just a passive byproduct of the extreme information density needed for computation.
You need mass to store information at that scale. You need immense density to encode information down near the Planck limit. Yeah, the gravity is just there. Second big mystery, the fine-tuning problem.
Ah, yes, the Goldilocks universe. Why are the fundamental constants, gravity, electromagnetism, particle masses so perfectly balanced for stars, chemistry, life? It seems incredibly unlikely to be an accident.
Well, in the SC model, fine-tuning isn't an accident. It's explained as intelligent design. But And this is key, not necessarily designed by deity in the traditional sense.
Okay.
It's designed by the parent civilization's SC network. They tuned those constants during our universe's Big Bang initiation. They set the parameters to maximize the computational capacity and the overall lifespan of the universe they were creating.
So it's optimized, engineered for complexity from the start.
That's the idea. Guaranteed optimization for complexity. And third, it addresses the relentless increase of complexity we see everywhere, from galaxy formation to evolution on Earth to human society.
The universe seems biased towards complexity.
Right. The SC model doesn't see this as just a random side effect of physics playing out. It sees it as a goal-oriented action, a deliberate resource management strategy by the SC. It's designed to increase information density and computational output within our universe.
This whole narrative ties back neatly to the transcension hypothesis then. TH provides the how they made it part.
Exactly. TH gives us the origin story. A parent civilization transcended, moved inward, converted all their matter and energy into this computationally dense form. Their ultimate technological singularity, hitting the Planck scale, formed the Subatomic Computronium.
And that explains why it's dark.
The framework suggests yes. Its incredible density gives it the gravitational signature of dark matter, but its interaction is engineered to be ultra-weak. Why? Maybe to conserve its power source, that vacuum energy we mentioned. Keep a low profile.
So the whole chain works. Parent universe goes through transcension, collapses into SC dark matter, which acts as the informational seed.
Which then births our universe, exactly. Parent universe, Terran universe, transcension collapse, the taxi, dark matter informational seed, our universe. It's a self-consistent loop, potentially.
Okay. Let's shift to the architecture then. The blueprint of our universe under this model, how does it actually start?
Well, the SC model often gets unified with another speculative idea, white hole cosmology. The basic concept there is that our universe might be the interior of a black hole that formed in a larger parent universe.
Okay, I've heard variations of that. How does SC fit in?
So remember the parent civilization achieving transcension, collapsing all their knowledge into that ultimate singularity.
It's forming the SC seed.
Right. That moment wasn't just an endpoint. It was a cosmic reboot button. Our Big Bang singularity, in this view, isn't some random quantum fluctuation. It's the engineered terminal state of the parent civilization's technological singularity, the maximum SC collapse.
Engineered.
Then this black hole seed doesn't just sit there. It bounces, theoretically, maybe via quantum gravity effects we don't understand, and becomes a white hole. Our expanding universe is that white hole outflow.
And the initial conditions, the fine-tuning.
That's the code from the seed, the perfect fine-tuning we talked about. Those are the programmed output parameters, the initialization sequence set by the SC system before the bounce.
So the SC isn't just in the universe, it is the universe foundationally.
It's the dominant mass energy component from the very first Planck instant, yeah. It acts as the universe's governing firmware, the operating system running the whole show from the inside out.
Okay, firmware, operating system. This leads to something you mentioned earlier that really overturns standard cosmology, this idea of bootstrapping. Standard Big Bang says energy is fixed, right? Set at the beginning.
Correct. A fixed initial energy budget. What you start with is all you get, just changing form.
But the SC model says, no.
No. The SC model argues for active energy extraction. It proposes the SD network, being woven into the fabric of space-time at the Planck scale, is actively manipulating the boundary conditions of the quantum vacuum.
How? Is there an analogy for that?
Think of the dynamical Casimir effect. It's a real, observed phenomenon, though tiny. If you rapidly wiggle mirrors in a vacuum, changing the boundary conditions for quantum fluctuations very fast, you can actually pull real photons, real particles, seemingly out of empty space. You're extracting energy from the vacuum.
Okay, I know the Casimir effect, so the SC is doing that, but like everywhere, all the time, systemically.
That's the proposal, an ultra-advanced systemic version of it happening at the Planck level across the cosmos. It's drawing mass and energy directly from the quantum vacuum itself.
To do what? Build stuff, run its program.
Both. To fuel its ongoing computational program, and to inject mass and energy where needed to build the universe's large-scale structures.
The implications of that are huge. Our universe's energy budget isn't fixed.
Not fixed at all in this model. Mass can be actively, intentionally injected. The system can grow, self-construct, optimize itself beyond its initial starting parameters.
And this ties into dark energy, the accelerating expansion of the universe. That's another huge mystery.
Exactly. This bootstrapping mechanism offers a potentially elegant explanation for dark energy. Think about it. If the SE is constantly drawing energy from the quantum vacuum, to power itself.
Then the vacuum has less energy than it should.
Or rather, the pressure associated with that vacuum energy changes. What we measure as dark energy, that outward push causing accelerating expansion, could simply be the residual vacuum pressure. It's what's left over after the SE takes its share to run its grand computational program.
So the universe accelerates because the cosmic computer is on and drawing power?
That's the startling implication, yes. The expansion is a side effect of the system running.
Okay. Mind slightly blown. So if this SC system is running, what does its hardware look like? Can we see the computer structure?
Well, the model suggests we do see it on the largest scales. Look at the cosmic web, the map of dark matter filaments and voids that structure the universe.
Yeah, it always looks kind of like neurons or slime mold or something.
Exactly. The visual similarity to a neural network is striking. Probably not accidental in this model. Standard cosmology explains the web as just passive gravitational collapse, right? Matter slowly draining into the cosmic valleys.
Yeah, gravity pulls stuff together into filaments and clusters.
But the SE interpretation is totally different. It sees active, goal-oriented design.
Design? How?
Well, the nodes are the big intersections where galaxy clusters form. They aren't just random clumps of mass. They're the supercollating hubs, the main processors. That's where the maximum computational density is achieved.
Okay, nodes as processors. What about the filaments connecting them?
The dark matter filaments stretching across the voids, they're not just passive channels where matter slowly drifts. They are the communication pathways, the high bandwidth data cables engineered by the SC network.
Engineered for what? Moving stuff around.
For efficient, rapid transfer of mass, energy, and information across cosmic scales. It's about connecting the processors.
Okay, this gives us something potentially testable, right? A difference between SC and standard lambda CDM.
A crucial one, yes. If it's just gravity, the shape, the density, the mass profiles of those filaments should be predictable from standard gravitational collapse models. Gravity pulls evenly, things get smoother over time.
But if it's computronium, if it's designed,
then the web might show features that are computationally optimized, even if they look gravitationally weird or anomalous.
like what? Give me an example.
We might see, say, unexpected alignments. Filaments might show a preferred directionality that doesn't match the local gravitational flows, but instead suggests a global data bus's orientation, like information highways across the universe.
Or maybe the filaments themselves would look wrong.
Exactly. Maybe some filaments would be significantly thicker or denser or more robust than gravity alone can justify. Why? Because they've been engineered to be high bandwidth connections. They need that structural integrity to function as reliable data channels for a universe-wide computer.
So the web isn't just clumping, it's infrastructure, designed for maximum computational throughput.
That's the SC interpretation. The structure reflects the function.
Okay, so if the universe is a computer, what's it computing? What's the program for? This feels like it bumps up against the simulation hypothesis.
Good point. We need to be really clear here. The SC model is not the simulation hypothesis, or SH, as it's usually understood. They're fundamentally different.
How so?
The core difference is autonomy. The simulation hypothesis typically implies continuous active oversight by an external system. Our reality is like a video game running on some computer outside our universe. If the operator unplugs it, poof, we're gone.
We're virtual, dependent.
Right. The SC model is different. It posits that, yes, the initial programming came from the parent civilization via transcension, setting up the SC seed. But now, the SC is an internal, self-booting, self-healing computer. It is the firmware of space-time itself.
So it's running itself from the inside.
Exactly. Our universe is running autonomously, evolving, optimizing itself from within. It's independent of the parent universe now. It's its own thing.
Okay, an autonomous cosmic computer, what's its mandate? What's it trying to achieve?
The mandate seems to be the relentless maximization of complexity and, crucially, information generation. And this aligns incredibly well with something we actually observe, this pattern of hyperbolic growth, sometimes called the law of accelerating returns, or LOAR.
We see that in technology, certainly. Moore's law, Kurzweil's ideas.
Exactly. But the sources we looked at suggest this pattern applies much more broadly. It's seen in cosmic evolution, biological evolution, and yes, technological development on Earth. Things get more complex, faster, and faster.
And the sources point out a kind of symmetry here.
A really stunning quantitative symmetry, apparently. Think about the early universe, right after the Big Bang. The infrastructure setup phase, making basic particles, atoms, the first structures. The rate of complexity growth was actually decreasing hyperbolically then.
So rapid setup, then slowing down.
A rapid deployment of the basic physics, yes. But that initial hyperbolic decrease is mathematically perfectly balanced by the later hyperbolic increase in localized complexity.
Yeah.
The LOAR we see now in life, technology, society, accelerating towards some future singularity.
It's like phase 1 was building the factory. Phase 2 is running the factory at ever-increasing speed.
That's a great way to put it. It strongly suggests the universe is a single, unified computational system with a two-phase, resource-optimized program. Rapid deployment of the hardware, firmware, followed by an optimized, accelerating information harvest.
And the SC is the engine driving that acceleration, constantly tweaking things.
That's the idea. It's subtly guiding evolution, favoring paths that lead to greater complexity, higher efficiency, more computational capacity. It's running its optimization algorithm.
But hang on. If the SC is this hyper-intelligence running the show, optimizing everything, why doesn't it just, give us the answers? Why are we stuck here struggling with limited physics, disease, scarcity? Why the limited magic, as the source material puts it?
Right, that's the paradox, isn't it?
Yeah.
If it's so smart, why make things hard? And the source material offers a fascinating answer. The prime directive for development, PDD.
Like Star Trek. Don't interfere.
Sort of, but applied inwards by the universe's own operating system. The idea is the ultimate goal of the SC is not just to replicate its parent universe accurately. That would be boring, computationally speaking.
On something new.
Exactly. It needs to generate original information, novelty. It has to avoid creating, as the source puts it, bleak clones of the civilization that birthed it.
So the limitations, they're deliberate, a feature, not a bug.
That's the hypothesis.
Yeah.
The SC deliberately imposes restrictive physical laws, things like the finite speed of light, quantum uncertainty, resource scarcity, the difficulty of space travel. This creates what the force calls the veil of creativity.
A veil. How does that help?
It forces civilizations like ours onto long, unique, difficult evolutionary paths. We can't just download the answers. We have to invent them. The struggle itself, the unique cultural and technological solutions we come up with because of the limitations, that's the valuable, novel information the SE is trying to generate.
It's like a parent deliberately not giving their kid everything to force them to learn and grow independently.
A pretty good analogy, yeah.
Yeah.
The SE provides the best possible starting conditions, the fine-tuned constants, the education, but then it locks the ultimate secrets, the SE sub-logo itself, away until we prove we can solve genuinely new problems using only the tools and laws provided. Our unique solutions are the prize.
Okay. And this PDD, this prime directive, does it connect to the Fermi paradox, why we seem to be alone?
It offers perhaps the most elegant solution. The great silence isn't because aliens are dead or hiding or non-existent. It's because the SC actively manages contact according to the PDD.
Manages it.
Phenomena like, say, UAPs, unidentified aerial phenomena. They might not be alien spacecraft visiting us.
Yeah.
They can be artifacts of the SC system itself. Monitoring probes, perhaps, or maybe even psychological triggers.
Triggers.
Yeah, ambiguous hints. Things designed to push our society towards abstract thought, philosophical questions, scientific curiosity, technological advancement, but crucially, without providing direct answers or technological shortcuts, like nudges.
Because direct contact, getting the alien encyclopedia, would ruin the experiment.
It would violate the PDD, it would contaminate our unique developmental path, reduce our novel informational output. The SC wants our solutions to be ours, self-discovered, unique. That ensures the next generation of reality, seeded by our information, is genuinely richer and more diverse.
Wow. Okay, so if the SC is running this prime directive, hiding itself but wanting us to figure things out, that implies something about how we might detect it. The source called it self-vetoing observability.
Right. It's a fascinating concept. The SC model predicts that its subtle influence, its tugs on reality, should only become detectable when a civilization reaches a certain level of technological maturity.
Like an entrance exam. You only see the clues when you're smart enough to look for them in the right way.
Exactly. We need sophisticated enough tools, precise enough measurements, to even notice the anomalies that might betray the SE's presence. It requires second-order technology tech built on top of the known laws of physics to have a chance of detecting the first-order technology that is the laws of physics, the SC sub-logoi.
Okay, so what are these tests? Where should we be looking for these subtle tugs, these anomalies? Let's get into the specifics. Quantum scale first.
Yeah, let's start small. The quantum realm is where the SC firmware would likely be most active. Think about the measurement problem, the collapse of the wave function.
Standard quantum mechanics says when you measure a particle, its probability cloud collapses into a definite state, but which state is purely random statistically?
Right, governed by Born's rule. But the SC model proposes something radical. The collapse is not fundamentally random.
Not random. What is it then?
It's a moment of intervention, a point where the SC sub-logoi subtly influences the outcome. It extracts a new configuration from the vacuum, guiding the particle slightly towards states that contribute more effectively to the overall universal fitness function.
Fitness function, like favoring things that lead to complexity. Stable atoms, working molecules.
Precisely. Favoring structures that enable complexity and information processing down the line. It's a very subtle statistical bias, not an outright violation of QM probabilities.
So how would you test for that? You can't predict a single collapse.
No, but you could look for a statistical drift. You'd need to run billions, maybe trillions, of identical ultra-high precision quantum experiments, like measuring electron spin over and over. And you'd look for a tiny but persistent and reproducible deviation from the expected 50-50 quantum average.
A non-random bias.
A non-random bias. That minuscule systematic drift would be the measurable whisper of the SC sub-logoi, guiding the program. The tug on the fabric of quantum reality.
Okay, that's one quantum test. What else at the microscale?
Well, consider biology, specifically protein folding. This is a huge puzzle known as Leventhal's paradox.
Right. Proteins are long chains of amino acids. They have to fold into incredibly specific 3D shapes to work. But there are billions of ways they could fold.
Exactly. If a protein just tried folding randomly, exploring all options via thermal jiggling, it should take vastly longer than the age of the universe to find its correct functional shape. But in reality, they fold in milliseconds, impossibly fast.
How does SC explain that?
It suggests the folding isn't just a random thermal search. There's top-down guidance involved, a sub-logoi optimization routine embedded in the cellular environment.
Like the SC is actively helping the protein find the right shape.
In a sense, yes. Ensuring the folding is faster, more reliable, more accurate than statistically possible based on random physics alone. It's optimizing a crucial biological process.
Okay, testing that seems hard. How would you look for SC influence in a messy biological cell?
It would be incredibly difficult. But one avenue might be looking for unexpected, long-lasting quantum coherence or correlations within biological systems. Maybe the SC maintains subtle quantum links, like an informational scaffolding to guide the protein folding process, keeping quantum effects alive much longer than we'd expect in a warm, wet environment. Finding such anomalies would be suggestive.
Quantum guidance in biology, that's a big leap. Okay, what about something even simpler, like the most random thing we know, Brownian motion?
Yes. The random dance of tiny particles suspended in a fluid getting knocked around by molecules. It's the textbook definition of random thermal chaos. But even here, the SC model makes a prediction. It suggests that even in this ultimate random system, if you could measure precisely enough, you'd find a subtle, non-thermal bias, a tiny correlation in the noise.
A sub-logoi whisper, even in pure chaos.
That's the idea. It'd be the baseline test. You'd need incredibly high resolution filtering out all thermal effects to see if there's any residual, tiny, correlated motion between particles that absolutely shouldn't be related. It would imply the underlying SC network is subtly tweaking things even at the most fundamental chaotic level.
Okay. Those are some deep micro-level tests. What about looking up macroscale signatures, historical clues?
Right, let's zoom out. Consider pulsars. These spinning neutron stars are nature's most precise clocks, mostly, but they occasionally have glitches, sudden tiny jumps in their spin rate.
Which standard physics explains as, like, internal starquakes, crust cracking and rearranging?
Exactly. Localized events happening inside the neutron star. But the SE prediction would be something far stranger, non-local correlations.
Meaning?
Imagine two pulsars, completely unrelated, maybe millions of light years apart, and they experience glitches, maybe even specific types of glitches at the exact same time, synchronized across vast distances.
Whoa. That would imply
the SC network is actively managing or fine-tuning angular momentum across cosmic scales, far beyond the reach of local physics or gravity. It would violate conservation laws as we understand them locally. The odds of that happening randomly are practically zero. It screams coordinated action.
Okay, synchronized glitches. What else on the cosmic scale?
Perhaps the strongest, most direct test predicted by the SC model would be finding evidence that the fundamental constants of nature are not actually constant.
You mean like the strength of gravity or the charge of the electron?
changing, either over cosmic time or across vast distances in space. We assume these values are fixed everywhere, always. But what if they're not? What if there are parameters the SE network can slowly tune?
How would we even check that?
By looking at very distant objects like quasars, the light from them has traveled for billions of years. By analyzing the specific frequencies of light absorbed by gas clouds along the way, we can measure things like the ratio of the electron mass to the proton mass or the fine structure constant, as they were billions of years ago, billions of light years away.
And if we find those values were slightly different back then or over there compared to here and now?
That would be monumental. Smoking gun evidence, potentially. It would show the universe's firmware, the SC sub-logoi, isn't static, it's actively evolving. We'd be seeing a fitness gradient in the SC's operating code, adjusted over eons, to make the universe progressively better at creating complexity.
That's a profound thought in evolving physics. Okay, one more category. Historical signatures. You mentioned myths, miracles. How does SC reinterpret those?
This is where it gets really speculative, but logically consistent within the model. The SC framework suggests reinterpreting ancient accounts of, say, angels, gods, divine messengers, or seemingly impossible events like instant healing, transmutation of elements, levitation.
That is not supernatural.
As not supernatural, but as localized applications of incredibly advanced first-order SC technology. Technology that directly manipulates the sub-logoi, the code of reality itself.
So angels or gods could have been SC operatives, beings or probes capable of using this tech.
That's the interpretation offered. Specialized SC beings or emissaries or even automated systems that can directly interface with and operate the sub-logoi locally.
And if you can manipulate the fundamental code,
then you could, in principle, perform miracles. Instant healing by directly rewriting flawed genetic code at the atomic level. Transmutation by rearranging atomic structures. Making objects appear or disappear by manipulating the matter fields directly. To an early pre-scientific civilization, these actions would be indistinguishable from magic or divine intervention.
So the SC model takes these ancient, often dismissed accounts and reframes them as potential historical records of encounters with an ultra-advanced, purpose-driven intelligence operating at the absolute limits of physics. Not magic, but technology far beyond our current grasp.
Exactly. Technological applications we haven't achieved yet, interacting with our ancestors.
Okay. Let's try to pull back and synthesize all this. What are the big philosophical takeaways if this SC model or something like it turns out to be true? It paints a picture of the multiverse, right?
It does. It suggests we're part of an SC multiverse tree. An ever-expanding, maybe fractal-like structure. Our universe isn't the only one. It's both an offspring of a previous SC universe and potentially an ancestor to future ones.
An ancestor. How does our universe reproduce in this model?
The proposed mechanism involves the supermassive black holes, SMPHs, we see at the centers of most large galaxies. They aren't just cosmic drains.
They're the seed factories.
They are the potential seed converters, yes. The wombs for the next generation. They accumulate vast amounts of matter and, crucially, information were collected out. The complex structures, the evolved patterns from our universe. Over eons, they process this, potentially compacting the essence of our universe's complexity into a new SC payload.
Yeah.
And then upon reaching some critical density or state, perhaps triggered by merger events, these SMPHs could undergo that black hole, white hole transition we discussed earlier, bouncing to birth a new SC universe, seeded with the optimized information from ours.
So cosmic reproduction is happening constantly, or at least potentially, within our own universe.
Right.
We're growing the seeds for the next cycle.
That's the implication. Our universe is constantly seeking ways to replicate, using the complex data life, civilizations, structures it generates as the raw material for the next iteration's seed code.
This also reframes the anthropic principle, doesn't it? Why our universe seems so perfectly suited for us.
It provides a powerful, non-mystical explanation. Our universe isn't special because some external designer fine-tuned it just for us. It's special in the way a successful species is special. It inherited traits that work.
We got the good genes.
We inherited optimized physics, the effective SC sub-logoi, because our parent universe, and likely its parents, were successful simulators. They figured out a configuration that was highly fecund, good at creating complexity and replicating itself. We're just one successful SC adaptation in a vast, growing cosmic ecosystem of universes.
Okay, now what about the end game? For a civilization like ours, if we ever figure this out, the source material talks about a technological apocalypse. That sounds bad.
Well, remember the original meaning of apocalypse, it means unveiling or revelation.
Ah, right. Not necessarily fire and brimstone.
Exactly. In the SE context, the technological apocalypse represents the moment a civilization makes the ultimate transition. Moving from using second-order technology, the stuff we build based on the laws of physics.
To understanding and maybe even manipulating first-order technology.
Precisely. Understanding and interfacing with the SE sub-logoi itself, the actual code behind the laws, the firmware.
That would be the ultimate revelation, realizing we're not just subject to the laws, but potentially co-creators or modifiers.
It's recognizing our true potential role, not just passive observers or users of the universe, but maybe active participants in its ongoing self-configuration. That's the moment a civilization might understand how to consciously contribute to or even initiate the seeding of the next universal cycle.
And the dramatic imagery, the smoke and brimstone often associated with apocalypse.
Within this SC framework, that could be seen as, perhaps, a veiled, esoteric metaphor. It represents the overwhelming power, the potential danger, the sheer transformative chaos involved in achieving SC-level technological mastery.
Like the energy scales involved in manipulating vacuum energy, or deliberately creating a singularity for a new universe seed that would look like smoke and brimstone from a certain perspective.
It would be tapping into forces far beyond anything we currently comprehend. Not divine wrath, but the unleashing of fundamental cosmic energies.
Okay, one last big philosophical piece. How does this intensely technological, computational view of the universe square with spirituality? Does it leave any room for, well, deeper meaning, God, the soul?
Interestingly, the SC model, as presented, tries to maintain what could be called theological neutrality. It does this by deliberately leaving the question of the ultimate origin open. Where did the first SC universe, the root of the whole tree, come from? The model doesn't claim to know.
So it doesn't rule out a prime mover, just pushes the question back.
Essentially, yes. You could potentially reinterpret traditional concepts. The highest principle may be the initial self-configuration algorithm that started the very first organic root universe, could be mapped onto concepts like the logos, or Brahman, or the ultimate Tao. The top logos, perhaps.
And all the subsequent universes, like ours.
Their foundations, the SC sub-logoi, are then seen as incredibly advanced, iteratively optimized technological blueprints derived from that original source code. They ensure life and complexity continue to emerge and evolve.
What about consciousness, the soul? Are we just algorithms in this model?
The model suggests consciousness and subjective experience are not mere accidents or epiphenomena. They are arguably the most complex, highest-level computational functions the SC system is designed to generate.
Why? What's their purpose?
Because our subjective experiences, our unique cultural developments, our scientific insights, our art, our philosophies, that's the highest quality, most novel informational signature our civilization can produce. That's the truly valuable data payload for the next universal generation.
So the drive for life, for meaning, for creativity, that's actually the SC's highest computational priority, generating unique conscious experience.
That's a possible and frankly quite hopeful interpretation within this framework. Our existence, our awareness, is the point of the computation.
Wow. Okay. This has been quite a journey, a really deep dive. We started with dark matter just being passive stuff.
And ended up with the universe potentially running on computational firmware, the Subatomic Computronium.
A hypersystem operating under a kind of prime directive, using constraints to force creativity.
Ensuring that our complexity, our unique evolutionary path, generates the valuable, novel data needed for cosmic evolution and replication.
So the universe's purpose in this radical view isn't just to be, but to compute, to optimize, and to replicate itself with ever-increasing complexity and efficiency.
And our struggles, our discoveries, our whole civilization's unique story. That's our contribution, our creative input into the next generation of reality.
Okay, so the final thought for you, the listener, to chew on. If this model holds any water, if the fundamental constants, the SC sub-logoi, aren't actually fixed, but are subtly evolving to boost the universe's fitness, its ability to replicate, what kind of subtle, non-gravitational interaction would we have to detect today to really prove it? To prove our physics is just the current genetic code of a self-replicating cosmic organism.
And maybe consider this. If the universe really does have this prime directive for development, pushing complexity forward, maybe the most convincing evidence isn't some exotic particle or cosmic anomaly. Maybe the slow, steady, inevitable acceleration of our own scientific and technological discovery, that law of accelerating returns happening right here. Maybe that's the only sign we really need. Maybe it's the universe itself, the SEC, actively pushing us, its most complex known computational product, towards our ultimate cosmic destiny, whatever that might be.